Okay, so I go from there. Whoops. Okay, so I just want to check sound and visual, making sure you're getting it. I'll close off the panel to the side. If someone could call me back and give me I guess, a voice check on that, I think it should be fine, but just want to make sure it's being clear. So if you can give me a buzz back on my phone, that'd be super. I'll wait for that. Hey,
You're good to go.
yay team, rah rah, rock and roll, good. Okay, well, I guess that's fine. I'll just sit here with this, just leave it in the same mode until we get going, correct?
Yep.
All right, we're looking good. I'll start talking right at noon. Give them 2 or 3 minutes like we talked about, and then hit the go button.
Oh, sounds good.
Hey, thanks, Joel. Appreciate your help. You're wonderful.
Talk soon.
All right, bye.
Bye.
Good morning, Randy.
Hello?
Randy?
Yes.
Hey, it's John. How you doing?
Oh, it's John. Okay, sorry. I was in the other room just writing some notes down. Doing fine. Got your news slides up there. If you're on it, you can probably see it.
Okay, very good. Everything all right?
Oh, good. And so the volume's good. I checked. We just had another test with Kimmy and so forth. And after yesterday's situation, with the password being an O versus a zero versus an O, hopefully we can get that changed. But no big deal. They've been great.
All right. Very good. Looking forward to it.
Okay, me too, John. Thanks. Talk to you in a little bit.
Yeah, thanks, Randy. Bye.
Uh-huh. You betcha. Okay, it's 12 o'clock East Coast time. Let's give it a few minutes for some other people to sign on, and then we'll get started in a couple of minutes. Let's see, we've got 50 at this point, about half of what have signed up. So again, a couple of minutes. Hopefully you'll do it. If not, we'll get going. Okay, well, let's get started. Welcome to the Icing-Leupola Engineering webinar for today, January 10th, 2020. First of all, Happy New Year, and I guess Happy Decade. My name is Randy Nicholas. I'm a senior engineer for Icing-Leupola, focusing primarily on residential construction. Part of a team of engineers, John Bruniak, who's our engineering manager, who covers everything. And then Jay Saldana, another senior engineer, he focuses on commercial construction. So just to let you know, anytime you have various questions, we work as a team to make sure we can get out there and support whatever your needs are in the field to promote our products. So with that, a couple notes. I think it's automatically muted, but please make sure if you're on phone, to mute your phone. And then we're going to take questions at the end. There is a place if you're on the webinar on a computer where you can type in a question, and again, we'll take care of that at the end. Hopefully we'll have 10 to 15 minutes for that Q&A period. We'll just see how it goes as we go through it, but try to keep you on time and back to your busy schedules. Okay, so first of all, we're going to look at the performance compliance path. And our learning objectives today, the basic one is we want to introduce energy code compliance using a performance path versus the typical prescriptive path. And I'll explain that as we go down, okay? To do that, we're going to review the IECC Energy Code compliance paths that are available to us. Number one, prescriptive path. Those are the R value tables that most of us are very familiar with. But the IECC also gives us some options, performance paths, one of which is simulated performance alternative. There's also an energy rating index, or an ERI path, that came in the 215 code, model code. And then there's ResCheck and ComCheck, and we'll talk a little bit later about those two programs, ResCheck and ComCheck, and how they really aren't very effective in doing trade-offs or reducing energy insulation in the attic area. There is energy modeling software that can be used to show that spray foam can meet requirements with less than prescriptive R values, and that's sort of the goal here today, is to look at the various ways that we can do that, and again, be more competitive in the field. We're going to look at when software is needed and who can run the calculations. That's an important part of it. We'll touch base on that. What information is needed to actually run the calculations that you either provide to the builder needs to provide to the energy consultant. And then at the very end, we'll just look at residential versus commercial construction considerations as far as performance evaluation and those type of things. So that's where we're heading today. All right, so let's get started. This is all about a legal way to meet energy code requirements at R values lower than the prescriptive values. And all we mean by legally is that there is a code compliance path to do that. It's not a matter of, gee, I think R20 is good enough, let's just do that. But this gives us a code compliant method to do that. And it's very clear in the codes, which I'll explain as we go along. The performance path can be used to optimize or reduce spray foam thickness at exterior walls, primarily underside of roof decks and unvented attics and ceilings. That's where the high R values are. Foundation walls, cantilevered floors, and so forth. So we can look at doing trade-offs based on the air tightness that the spray foam gives us for the overall performance of the building. All right, so one of the things I want to get started with is I get a lot of calls, or I get these type of conversations that the code officials are told that R20 spray foam performs the same as R38. That is not true from an R value standpoint. That chart, although I wish it was there, does not exist currently. And the reason for that is R value is R value. It's based on a specific test, ASTM C518, which is the standard test method for steady state thermal transmission properties, or as many of us in our field call it, the guarded hot box. That's what it's based on. The key thing to note about when they're looking at this test and running the various products through it, the test does not account for air leakage. So we, in the spray foam industry, the air tightness industry, do not get any credit for the air leakage, the enhanced performance that building air tightness gives us. So again, R value is R value. We have to prove that through these various methods under performance. So that's a big part of what we're heading for today. All right. Couple things, the IRC Chapter 11 and the IECC Chapter 4 are really the same documents. They came together in the 09 code. They were different charts and different R values, which was a real problem in the code. So anytime we're talking about the IRC Chapter 11 or the IECC Chapter 4, they're essentially identical sections. They're just different code bodies. So that's an important thing to look at. So now we're going to kind of compare them. What's been happening? The 2009 codes took a jump, about 15% more stringent than the 2006. Basically what happened in 2006 is the Department of Energy decided to come up with this 50% rule where they were going to try to reduce the energy consumption of buildings based on the 06 code by the year 2015, that it would be 50% less energy needed. So that was the goal. So the codes have produced along 2012, 15, and 18. They're about 30% more stringent than 2006. So we're not at the 50% solution is what it was called, but we're getting there. And we'll kind of go through the prescriptive charts in just a moment so we can see how that works. Now, the other thing that's really important is when you look at the IRC Chapter 11, the IECC Chapter 4, those are model codes. That's what the DOE and ICC puts out saying, okay, this is the template. This is where we start. Then what happens is that model code is brought into the state and local jurisdictions, and it goes through a committee process and politics and different things. So typically the model code is almost never adopted exactly the same as the model code. So the state code and local codes are different. You also have the idea or the problem that we run into, builders do too, that some cities are within a county and the city and county have different R value requirements in different codes. So it's important always to check obviously where you're building, because 1 foot across the line can be a different code. So just realize that what we're mainly talking about today are model codes, and then you have to dig into it for state and local amendments where that places the energy requirements. What we've got here is a map of the residential energy code adoption. This is current as of 1/1, the best picture of it, if you may. They're all different colors. You can't read the small lines, but this comes from a group called Building Codes Assistance Project. This is the website, bcap-energy.org. And so you can get on that website, and if you'll get a map of residential, commercial, and then you pick a particular state and you'll see what those code amendments look like. Same thing on the commercial, again, various. Oftentimes too, the residential code and the commercial code can be in different numbers. Somebody may take an 09, but now we're on the 12 IECC and we're on the 09 IRC, and it gets to be difficult. The thing is, always check with your local code officials as to what is needed and what is required of us. So when you click on a state. This is the kind of information you get out of it. This case is New York State. It shows you the climate zone, so you know the differentiation is what's required. Commercial code in New York State, it's the 016 code of the statewide, but it's based on the 015 IECC and ASHRAE 90.1, the 2013 version, as modified by the 216 supplement. This is where the state and the local jurisdictions will change that. Same thing on the residential, based on the 215 IECC as modified by the 216 supplement. So there's almost always changes. New York State actually did a pretty good job, or almost adopted entirely the same code. So as a result of that, you can see here, can use ComCheck and can use ResCheck. There is a program that's tuned in, that's developed by DOE to support that, as long as the code has not been weakened or lowered. That is, R values are not lowered or air tightness levels haven't been raised from the model code. And again, we'll look at the ComCheck and ResCheck and see how that does or really doesn't play in to helping us get into the ability to reduce those R values, again, primarily in the ceiling and the unvented roofs. So the energy code, the IECC, and of course the IRC in their energy section allows several compliance paths, and that's a good thing. So the first one is prescriptive requirements. Those are the R value tables. We'll go over those in a minute. And these are the table numbers based, again, on the model code. The state code numbers, usually these last two dots may change, but it's essentially IECC R residential 402.1.2 under the IRC N 1102, chapter 11, 02 1.2, and under the IECC commercial 402 1.3. So that's where the tables are in the model code. Each state, again, will have maybe a different set of numbers, but there will be a table for prescriptive requirements. The other thing to note is that prescriptive requirements don't actually line up with, or not exactly equal to, the mandatory. So mandatory provisions, which are not on the prescriptive tables, include things like air leakage control, duct sealing, solar heat gain coefficient for windows, etc. So there's a whole list of mandatory things that have to be met in addition to prescriptive, and that's an important factor. So just because you meet the prescriptive requirements, to make sure that indeed, especially in terms of the air leakage control, that we're in compliance with that. So 2006 IRC Chapter 4. This is just a rundown. Now, like this set of charts and the two maps I just showed you, those vary constantly. I tried tracking this for literally a couple of years, and it seemed like it changed not daily, but you kind of never knew with 50 states and all these different jurisdictions where it was. So this is sort of a snapshot. It may change tomorrow. It probably will. Codes are always marching forward. Right now, we still have 2 states on the 06. 8 states either have an older code or no statewide code at all. So that's just kind of a jump on that. So that's where that characteristic comes in. Spray foam house, we know that a 1.5 ACH 50 house, the energy performance is far superior compared to a conventional fiberglass house that is around 10 ACH 50, very loose back in 06. And that's about what we saw as sort of an average. And it's due to the increased air tightness, not so much the R value, but the air tightness. In the 06 code, mechanical system trade-offs are allowed in the performance compliance path. We'll look at that a little bit later, but it just means that back then, if you put in a higher efficiency HVAC system, you actually got credit for it, and you can then trade that off for R values, i.e. lowering R values. The other thing that's important here is 2.6, it's the base code for level for the future revisions of the code. So everything kind of started with 2.6, and then we start ramping the codes, getting more energy efficient. So 2009, Chapter 11, under the IRC or IECC Chapter 4. Again, basically the same documents, just in different code bodies. 14 states are currently on it, and this code called for a 7 ACH 50. And so we know that a 1.5 is still performing much better, so we had some good trade-offs based on air tightness. Now, back in 09, and some of the codes still currently, a blower door or a visual inspection was allowed to determine if or not they hit the 7 ACH 50. Visual inspections were there sort of as to placate everybody. People were afraid of blower doors. They were expensive. They didn't understand them. They thought they were $900 to $1,000 a piece, which they are not. They're typically $250, maybe $300, depending on location. So visual inspection was allowed. So you had your option. You can go around and look at it 1 or 2 times during the construction process and with a magic wand saying, okay, it meets a 7 ACH 50. Not very empirically correct, but it was allowed. Mechanical system trade-offs now are not allowed in the 09 and to today's codes in the performance compliance path. ERVs and HRVs are used to provide ventilation and boost efficiency in some climate zones where appropriate. There was no mandate for mechanical ventilation in the 09 code. Okay, then we get to the 12 code. We start changing things. 8 states currently use it. Air tightness levels lowered or decreased. We had 2 numbers really to work with between zones 1 through 8. The warmer zones were at 5 ACH 50. As we got into the more northern climates, 4 through 8, it was 3 ACH 50. Blower doors were then required on all houses. Again, model code, not necessarily state. We still have some state codes that are on the 12 and 15 and they're not mandating blower doors. So again, check to see what that regulation is. R values definitely increased. You can see these here, especially in the ceiling, going from an R38, I think it was climate zones 4 and 5. We also had the walls increasing from 13 to 20 or 13 plus 5, that is cavity plus continuous on the outside. Spray foam, at this point, since the requirement for air tightness, fairly tight buildings, not super tight, but pretty tight. It's all about, let's use spray foam because we can get there quicker. Time and detail, i.e. money, was required. So it put us in a much more competitive stance versus a fiberglass house that had to do a lot of extra air sealing to get down to these lower levels. Mechanical system trade-offs still are not allowed. At this point, mechanical ventilation is required. Okay, the key number is 5 ACH 50. The code doesn't actually label that, but because this particular code, the loosest building was a 5, and this code required mechanical ventilation, that really meant 5 is sort of the line in the sand that if you got tighter than, or up to 5 or tighter, then mechanical ventilation was required. So it depends on what zone you are, and again, what state and local jurisdiction accepted that and what they had in on their books. ERVs and HRVs were used to boost efficiency in some climate zones, again, part of the overall system. 15, we've got 17 states using it, same air tightness levels, pretty much required in all houses. That's good. Our values did not increase. That's also good. Spray foam, again, preferred because of time, detail. That's the cost effect required by fiberglass houses to get them anywhere near a 5 or a 3. Mechanical systems still aren't allowed, and mechanical ventilation is required. Okay, ERVs and HRVs are all part of that part of the house as a system. And in 218, not a whole lot of changes. There's 2 states using it. I think it might be 3 at now. I could not get that confirmed, but again, as states go on, we're going to be seeing more on the 18 code. It doesn't change a lot from the 15, and that's a good thing. So there we go there. So performance path. It gives us the option under these sections, i.e. section R405 or N1105, which is known as the simulated performance alternative. So this is another way to go about it. If you meet these requirements, the code complies with the building with the energy code. Okay, so the main part of this section is right here. Proposed design shall be shown to have an annual energy cost that is less than or equal to the standard reference design. The standard reference design is a building based on the prescriptive tables and 1102.1.2 R 402.1.2. So you run 2. You run proposed design, that's the spray foam house with the tighter envelope. You run it through the simulated performance alternative. And if indeed the energy cost is less than or equal to the standard reference design, that is the prescriptive house, then you're good to go. There's a lot of different softwares out there. One is REM Design, there's another one, REM Rate, there's Ecotrope, and there's Energy Gauge USA. So those are 4 programs that pretty much universally are accepted. Not in all cases, but for the most part, we do see acceptance by the code officials. They're familiar with it. As most of us know, especially in remote areas, some of the code officials are not quite understanding performance path and computer programs and so forth, but it's getting better. These do comply with the requirements set out under the DOE and the ICC as far as programs that can be used to show compliance under the simulated performance alternative. Okay, so here's what we're going to talk about. And this is really where it boils down. The computer modeling accounts for the spray foam's lower building air tightness, so its benefit can be realized. So it does factor into the calculations. That's very good. That's very important. And we know that spray foam houses typically come in around 1 to 3 ACH50. Those are homes that have either 6 sides of foam or maybe a slab on grade with walls and ceilings foamed. So we know that's very doable. Unvented only applications, say in a retrofit, or if the builder or the designer decide just to do an unvented attic to keep the ductwork inside the building, but use conventional insulation in the rest of the house, then we see roughly around 3 ACH50. It does vary, but certainly it still can be a very tight building, especially adding in that unvented attic assembly. R-value trade-offs between wall, floor, and ceiling and building air tightness are permitted. So if we have a tighter building, we can lower the R value in some of these components as long as the energy cost is the same or equal to the prescriptive design. Mandatory energy requirements still apply, so you don't get away from that. So this is the other parts, and there's a whole list of them, and I think we'll show that on one of the slides, the type of things that are in mandatory, but they're important, so all have to be met. This is a biggie. Mechanical system trade-offs, as I've said before, are not allowed from the 9 through the 18, including now the 21, which is still in progress. But so you can't use a higher efficiency furnace or an air conditioning system and get credit for it for trade-off. And the reason for that, it's kind of a goofy thing, but there's a prevailing minimum federal HVAC efficiency that are in the books. And so the codes are not allowed to require anything above those. I think the AFUE, as far as furnace efficiency, boiler efficiency, is 81, and I think SEER is 13. So what it means is that you put the same efficiency for the standard reference design and the proposed design, so there's no credit allowed. It becomes a level playing field. So keep that in mind. That's one of the things about performance. Even though the builder is going to use a very high efficiency piece of equipment, there isn't any energy credit given for that in this particular approach. One of the things that is needed, the builder certification typically is required. In other words, the builder goes back out after the house is built, looks at the building, makes sure that it complies with everything on the alternative that was designed, and signs it off. So there's a liability transfer to the builder saying, yep, we did all of those things. We should be in compliance, and for the most part, that's what the building code officials want to see, and that makes it work for everybody. All right, so performance path, we need a lot of info. It's a very detailed thing. I've done quite a few of these. In my earlier life, I did hundreds of these as an energy rater back in the 80s, and it's pretty detailed. Takes a lot of time, but that's a good thing. It's a complete construction set of drawings and project specs. Elevations, floor plans, there's a takeoff on the building envelope areas, making sure that, you know, in R value for the walls, we get all of the wall R value, and making sure you've got everything that's accounted for in the plan. So the plans, the complete part is very important. Proposed insulation levels of each component, floor, walls, and ceiling. Predicted building air tightness, this is what you're shooting for. So if we're going to run a 2 ACH50, a very tight building under the blower door test at 50 pascals, then it's a big part of that calculation. Fenestration specs, U factor, solar heat gain coefficient, etc. Those are part of it. Project orientation, how it's facing, north, south, east, or west on the particular building, or if it's in a development, it's the worst case. Typically where the most amount of windows are face north, and as long on this proposed design, and if indeed it passes that, then the building code official knows that the other orientations are going to be better. So there's sort of a do one rating, make sure the buildings are all the same, if you may, but that orientation is a big deal when it comes to looking at performance calculations. You do have to put in the mechanical equipment, that's part of the equation, but again, with this particular path, there really isn't any credit for it as far as the calculation behind it. It is entered, but it is not credited. So here we have a computer modeling to demonstrate the path. This was done, I think, back in 18, no, yeah, it was in 18. This particular building's in Albany, New York, which I think is climate zone 5. I think it's 5A, yeah, 5A. And this is the mandatory requirements that we talked about. These are the things that have to be done regardless of the R values. And as far as compliance, the things they look at are heating, cooling, and water heating. This is where the line is. So as long as designed, this would be the spray foam home. This would be standard reference design. As long as this number, 1729, is less than 1804, which it is, then this house would comply. There's another one that I got in from Performance the other day. It's a group we work with out of North Carolina for computer modeling and home energy ratings and a lot of other things that we look for. This particular home, walls were R13, roof R20, and this was a 2A CH50 house. Pretty tight house, which is good. And again, you can see sort of small, but the subtotal used for compliance, this number, 1001, is less than the other by just a little bit, 1005. But that's all the code requires, equal to or less than. And then this is the statement you're looking for. Design exceeds requirements for the North Carolina 219 performance compliance by 0.4%. It can be 0% as long as it's the same. And these are the requirements that are needing to be met. So some needs to check all of these off and make sure that in addition to the R value requirements and the air tightness requirement, other things need to be met. And this is done in a program called Ecotrope Rater. It's a web-based rating system that's out there. It's fairly new. It's one I've been trained on, both REMRate and Ecotrope Rater, and they seem to give you pretty similar results. Now, one of the issues that we have to kind of look through is, okay, great, now we need to do this. How do we find someone who can do this type of calculation work? The first one we would call on to be a ResNet rater, which is a HERS rater. There's ResNet network that you can Google. It has a finder, a locator of where the ResNets are based on location. So you can contact them, find out if they do it. I always think it's a good idea for our dealers to team up with various ResNet raters, work as a team. One, you provide them some work, if you may, and back to you from them. So it's a good relationship, and a lot of our dealers do use HERS raters for compliance path. Now they can either run, as we'll see in a minute, a home energy rating, or they can do the performance calculations under simulated performance. Not all of them do both. Some do, many do. It makes sense that they're a multifaceted company. Then you also have, separate of that, building envelope consultants. These are just companies that specifically work on building envelopes or energy consultants. You can Google either one of those for your area and find out who might be available to do that kind of work. So as far as finding one, these are just a couple I put up that we're aware of. Some are single state, some are multi-state, but these are just examples along with their website. This is Performance Point, which I mentioned earlier. North Carolina, but they also cover South Carolina, Tennessee, and Virginia. And when I looked at their map, they have projects in about 20 different states. So these are their focus points. Talking to Sam Galfin, who's their head at the agency, and they do some pretty darn good work. So Performance Point is one. Southern Energy Management, North Carolina, there's their website. Another one's PEG, the Northeast, Southeast, Midwest. Pretty much covers most of the country. Another one is SkyTech, Northeast, Southeast, California, and Oregon. And then the other thing, Energy Vanguard, which is one I've worked with. We've been very active with them in the Georgia codes in the Southeast. So these are just different agencies that you can contact to see if they can perform that. That's an assistance for the builder, and something that I think, because we're definitely in the energy business, we should be able to have some information. So these are things, as you look at using a performance path to comply with the code versus prescriptive, these are companies that can run those calculations based on code compliance. Another opportunity or option is the state code energy offices. They have a list of companies. Typically, you kind of have to dig down into their website. Sometimes it's difficult, or you can just hopefully contact them through an email and tell them what you're looking for. And typically they'll have a list of companies now, and it's getting better and better, of who does these calculations. So there's another avenue to find out what's happening. The other thing that comes up, okay, we're going to do these programs, but what does it cost? And right now, what I can nail down from various people I've talked to is somewhere in the range of $200 to $275. and that covers up to a 3,000 square foot residence, which is not a majority of, but I think the average house is 25 or 2,600 in the United States right now. So it does cover a lot. It just gives you an approximate cost. The actual number obviously is going to come from the individual group. One thing to note though, this cost is without blower door or duct testing. If indeed the code official says, great, I like the program, it looks like it's there, some code bodies, and I do a lot of code work, ask specifically, okay, prove it. At the end, you've got to do a blower door. So that's going to be in addition to that. I would have that discussion with those energy modeling companies or the HERS raters to find out in your jurisdiction what is actually required. So that's important note. So 200, 275 ballpark number, depends on the company, up to about a 3,000 square foot residence. And again, blower door, duct testing, or other things are not included. So if that's what's required, you want to be aware of that when you present it to the builder or the designer. That's what we're looking at doing. We're complying under simulated performance alternative, and this is what we're looking at. Okay. All right, let's get into the other software. So ResCheck and ComCheck do not account for tighter building envelopes. So building envelopes cannot be changed. There is no option to say, okay, we have a 2 ACH 50 house that maybe the state requires a 7. You don't get any credit. There is no way to change it. So really, their usefulness for airtight homes, tighter buildings, really it's pretty limited. ResCheck especially has been used pretty extensively for a number of years. And what has happened is as the codes increased energy efficiency, what has been happening is the window levels were fairly low. So if the builder put in, their designer spec'd in a really high efficiency window and standard reference design was a very low efficiency, there's some headroom or some credit you could get. That is not the case anymore. What's happened is the R value, especially in the attics, going from a 30 to a 38, some of them to a 49, that window differential doesn't help. Plus the window differential has gotten smaller because as the codes have marched on, the U factor or the R value of the window has increased. So it's really not there. And then as I think I mentioned earlier and try to emphasize, but if a state, any state or jurisdiction weakens the energy code, Department of Energy will not provide state-specific ResCheck or ComCheck programs. So most of the states that I've seen have weakened the code. That is, they haven't gone with as tight as the code requires or as high R values or something that increases the energy usage. So DOE said, okay, no more. We're not going to work with you. So these have pretty much gone by the wayside. The 215 code is where I started getting a lot of calls from our contractors and architects, and they were, can we use ResCheck? But it's not working anymore. We can't meet the requirement. So again, ResCheck, ComCheck, this is commercial, obviously, this is residential, really are not effective. And at this point, they're not useless, but they really don't help us. So that's kind of the other software we're talking about now. We have another option. This came in the 215 code. Okay, again, it's R406 or 11 and 1106. It's called the ERI, or the Energy Rating Index. So it requires a HERS rating. Home Energy Rater comes out, does a rating, and again, that started in 215. So in this path now, it does allow for equipment trade-offs. So you can have a higher efficiency furnace or a higher SEER cooling system and get credit for that, which helps lower that, typically, again, the ceiling or the unvented roof assembly R value requirements. There are these things called backstops. So what this code comes into, it goes, you cannot go below a minimum insulation prescriptive requirement. So you can't go a backstop. And the backstop, that's an R value, it's based on the 09 IECC. So whatever the values are in your particular region for the 09 IECC, you can't go below that in the 15 code. So you can trade down to that, so you can lower the R value to that backstop. Now, the other thing is noted in state documents. State documents, again, vary. So there's some digging that's needed typically to look at exactly what's going on in your jurisdiction where you're doing your building. A couple examples of this that we've been working with, and it takes time and effort, but it's worth it. In Georgia, when they were going through their code, which is now in effect in 1/1 of 20, we proposed and were successful at pushing through an R20 minimum backstop for an unvented attic or a cathedral ceiling versus the 2019 value of R30. So our dealers said, well, we don't want to go to an R30. What do? We got it through the code. It's about a year process to get it through with many different meetings and, oh gosh, a lot of politics. Everybody's there trying to fight on their side of the equation or not. But we did get it through Georgia. So that's now in effect as of, 10 days ago. So that's a good thing. North Carolina, basically the same code change proposal. It right now has passed all the committees and it's going through what they call financial impact review. I believe we'll be fine with that, but we've gone through all of the politics. Now it's a matter of the people crunching the numbers to see if how that affects the overall building, the homeowner, and that's everything is out there to protect the homeowner and the building owner to make sure that they have an energy efficient building. So again, Georgia, North Carolina, hopefully some other states we can get there, but again, we dropped that backstop from an R30, we got it down to a 20, and the same thing in North Carolina. So that's good news for our dealers, makes us more competitive versus our typical fiberglass or cellulose project that we're looking at. So the ERI, HERS rating, requires a detailed energy rating be performed. The energy rating can be done from plans, that's called proposed. So before you even start, you can do an energy rating and kind of tweak the numbers and make sure that you get it below that threshold number. And I'll talk about that in a minute, the actual index, what it means. But it's required to be third-party verified. So that's where the HERS rater comes in. So you do it proposed, you go ahead and build it. If everything comes out right, especially the air tightness, it has to be verified by a third party. So there's a blower door and a duct blaster if needed. Duct blasters are not needed, or duct testing is not needed if indeed we have an unvented attic because the ducts are inside the envelope. So that's another little bit of a cost trade-off that's not required with an unvented attic, which is a good thing for us. So again, that's the most important thing, proposed. So as you go into the project, the design comes in, you know it's going to pass as long as all the air tightness is there and all the other components. And then the HERS rater will again do a post-construction compliance rating, and as long as it meets all of the conditions, you're good to go. The data is then entered a computer program. Again, it can be the REM rate or Ecotrope right now. Those are the two main programs that are used by the HERS raters, and there's a variation of both. Some use one, some use both, some use the other. An energy score is generated, and the score does account for the climate zone. So the different climate zone numbers and different ratings. So here's where it kind of fits in. So just so you understand where the path is, the numbers, a score of 100 means that the house used the same amount of energy as a house built in 2006 under the IECC. So 100, no change. None of the states have adopted a score of 100 for compliance. And then the other end of the spectrum, a score of 0 would be a net zero house. You probably hear a lot about the net zero houses, typically with a solar panel up to make up for the energy that you have to use for most of your electrical. But so 0 to 100, that's the range. And what we know is that the states typically adopt a number. There are numbers in the model code based on each of the zones, the climate zones. However, the state itself, which I've gone through many times, will adopt some other number. Most of them are in the range of 50 to 60 as far as the index number. The name of the process, the game, is to get the index below whatever number is stated. So if it's a 50 or 60, it means that the house would use between 50 and 60% of the energy compared to a house built under the 06 IECC requirements. So that's really kind of how it fits in. 0, extremely energy efficient, 100, basically the same as a 2.6. So if you're going to use the ERI path, it's important to get below whatever that state or local jurisdiction has adopted for the index. So which performance path do you want to use? What's the most advantageous to achieve energy code compliance? It really depends on the state ERI rating values, where they stand. Is it easy to get to that number, or is it very difficult? And if mechanical equipment trade-offs are desired. So if you know your builder or the building is going to put in a 90% or 92% furnace and a 21 SEER efficiency equipment on the cooling, then there's a good chance this will work. But you have to kind of take that into account because you have options. As this is rolled out since the 015 code started being adopted in 16 and 17, they found achieving the ERI ratings really are actually a little harder than prescriptive. So at this point, not a lot of people are using the ERI path, although it's out there. It's an option, depends on your climate and a lot of other factors. It's something you can sit down and talk to the energy consultant and kind of get a take on what they feel is the best approach. to take as far as the energy modeling. We know that the simulated performance alternative, typically REM design, is what we've used for a number of years, probably upwards of 15 or 20 years, has worked very well for us because the algorithm of the calculation does give the right amount of credit for an airtight building. So simulated performance alternative, which is the option one, generally works best for us. ERI can work, but it just depends on a lot of different factors. Again, that's a discussion to have with the energy consultant. Okay, so computer modeling approach is one of the performance-based compliances on the commercial now. This is the difference. We'll just look at commercial just briefly. So it's pretty similar to residential. The thing is, and here's where the issue comes in. There's a couple of them. The inexpensive, easy to use, comprehensive software for commercial buildings just aren't available. Commercial buildings, as most of you know, are much more complicated than residential. You've got your interior loads, a lot of different things come about, a couple other things that play into that. So you do need to use a very comprehensive, but they're expensive, hard to use, or take a lot of time to understand. There's a big learning curve, and they cost somewhere between $4,000 and $9,000 for the consulting company produce an energy model in roughly 2 or 3 weeks. It really just depends on how busy they are, but that can be a big delay, especially when you're trying to get started with the project, or the engineer is, or the architect. So that's kind of the rub here. The other part that's kind of tough is, one, we see few instances, and mainly because of this and this, the expensive and the cost to run them, commercial building airtightness is unknown oftentimes. It's difficult to quantify due to multi-use. Say it's first level is commercial, and then above that is residential or mixed use building. And it mainly comes down to something called compartmentalization. And all that means is that inside of the building, each of those zones, that is, say a retail store, A, 1B, 1C, the energy loss or the air leakage between the building separation walls really doesn't matter from an energy standpoint. All you're really looking for is the air leakage to the outside. So in order to do these energy blower doors, what you have to have are multiple blower doors that are all synced together. So yes, they can be done. They typically are not done very often. So commercially, it's available through there, but there's a pretty good price tag to pay, and then trying to come up with the actual air tightness can also become pretty darn difficult, and unfortunately can be expensive. If you find a company with 5 or 6 or 8, whatever it takes, blower doors to equalize the pressure between the various compartments and then find the difference to the outside, that becomes a bit of a stumbling block. So with that, I'd like to open it up to questions. I'm just going to see what we have, if we have any out there. Kimmy, do you have any questions that have come in? We've got about 15, 16 minutes here. If there are any, let me check my panel to see if I see any. Jay is asking something, but let me click on it. Is it advantageous for installers to advocate not to upgrade HVAC and focus on building air tightness when using performance path? Yeah, I would say yes. If you're using the alternative, you can't take advantage of that anyway. And I would say that, there's always a trade-off between the various components, that is the HVAC system and the building envelope. They're both parts of the system of the building. So Jay, I would say that's correct. Good questioning. Meaning, does that help earn credits by use of foam rather than use of other expensive, let me scroll down, equipment? Yes. There's definitely an avenue. One, again, in the simulated performance, HVAC trade-offs are not allowed unless the local jurisdiction or state did that. And I don't know of any that changed that component. There may be some, but I'm not aware of it. And then it's, again, more advantageous for us to say, well, instead of going to the expense of going to more expensive, say, sealed combustion versus what you had in there to begin with, let's look at building envelope. Plus, you realize that the building envelope doesn't change over time, typically. It's a much better investment to get the building airtight versus just adding more money into the HVAC. Under the energy rating, the HERS rating, residentially, you can trade off HVAC equipment. Again, the nice thing about running the calculation beforehand is you can determine that. You can run several runs. Let's bump up the HVAC, or let's lower the air tightness and see where it gets us. Kind of look at, okay, what's the cost to get there and what's the bottom line? How do we get to that energy code compliance under the alternative, or in this case, the ERI path, to make it work. So Jay, I hope that answers your question. Amanda Hawkins, let me see this one real quick, like ResNet, resnet.com, I believe it is. I should know that. I don't really typically get on the site, but if you Google ResNet, you will find it. RESNET, Residential Energy Services Network is what it stands for. Okay, here's one from Aaron. How's Cal 25 with the performance path method? Can you add another section to the discussion to review the intricacies of California? Huge builder ops. No, I couldn't agree more. And actually for that one, not in this session, but that's something John Broniak, he's been very involved with California Title 24. It's another planet of energy, and I don't mean that sarcastically, but kind of. Title 24 is the energy piece in California, and it's very different than any of the other codes. It's getting closer, but John has been working on specifically unvented attics and making sure that indeed those attics get proper credit for the air sealing, one, two, the fact that the ducts are now inside the envelope versus outside. So John, maybe that's something we can address maybe in an email to the group that attended today, and I think that's probably the best way to handle that at this point. But that's a good question. Title 24 is very definitely a different set of circumstances. So I'll leave that one alone. Hopefully I've answered that sort of efficiency. Do the REM, this is from John Fleschner, and it's do the REM designs have to be performed by a certified HERS rater, or can it be performed in-house and verified by a certified third party? It can be done that way. Some states actually, if you're going to run this, some states require an engineer's stamp. Not all, but some do. Some jurisdictions I've seen do require that. So that would be a question directly sent to the jurisdiction, what they accept and what they don't accept. So I'm not going to make a blanket statement there, but typically, it would make sense that a HERS rater would do it, or you could do it in-house, and then the HERS rater look it over, and if they sign off on it and they don't need a stamp, that's fine. And if they do, some of the HERS raters like Performance Point do provide actual stamped ratings, so that's another good thing. Sorry I was late. Okay, that's fine. Sorry you were late too. And this is Alex. I'm not sure how to answer that question. Is it recorded? Yes, that's where we're coming in. Yes, it has been recorded. It will be available. Marketing will send that out, a link to that, so you can look at it. Okay, because the other question is from Al Leganema. It's because of IAQ concerns brought about by the lack of trust due to bad install press, how can manufacturers and installers provide confirmation that an install is tech data? I guess it meets the technical data. IAQ appears to be a greater point of concern for many designers and builders than efficiency. Well, it's really a combination of both. I think one of the things that we've seen, one, as some of us know, there can be, I guess, quote unquote, the bad install where the mix is off. That's certainly an issue. A lot of the concerns that I get on the engineering line is when we have someone calling in and they're talking about high relative humidities in the building and so on and so forth, or mold growing here or there. And my first question is, what have they done for ventilation? And I usually have to explain what ventilation means. That is mechanical ventilation. That's air exchange. What are you doing to bring fresh air in and get fresh and the exhaust air out? And that's a big part of the equation. So residentially, that's still in many states not a requirement, even though some of the states are at 5 ACH 50. They're not mandating mechanical ventilation. So we're kind of in a transition zone between really loose buildings and getting tighter and tighter. And once we pass that 5 ACH 50, now the building doesn't have enough natural ventilation. We need to add something supplemental to that. And we can bring in air from the outside. There's supply, there's exhaust, there's balance, there's heat recovery or energy recovery. All those methods work and are accepted by the code, but it's important that they're done right. So part of that issue with IAQ is our dealers teaming up with HVAC contractors that understand ventilation, and there's getting to be more and more. I still spend a fair amount of time with either HVAC contractors or dealers or architects trying to understand that on a residential side. On the commercial side, it's been in the code for a long time. Mechanical ventilation is part of the code. It has been, I don't know when it came in, probably in '89. And that's a good thing. We have a lot of people in a small space. We need to make sure we have enough ventilation to keep everybody happy and the IAQ in order. So that's kind of where it is. Manufacturers and installers provide confirmation. Well, if there's any issue, one of the things we have with the ability to test the phone to make sure that it's standard quality. It's a series of 5 tests that are run in our labs, so we can verify that indeed the install was right. Then the next question is, what's the problem with IAQ? Oftentimes, what people don't understand is compared to a normal conventional leaky fiberglass house, these houses are very tight. If we don't provide ventilation, there's a lot of things in the building that emit things. Carpet, paints, varnishes, some of the woodwork, some of the pre-finished wood can be a problem. So it's kind of a mixture of things, but the main thing is if you have a concern from a homeowner or a builder, there's an issue, give us a call. Let us talk to them. Let us figure out what's happening. Oftentimes the 3 of us figure out what's going on, make some recommendations, find out how things go. So that's kind of if there is a problem. Is the presentation available? Yes, again, it is available. Marketing will send that out and make sure that indeed everybody gets a chance. And the other thing is, gone through a lot of things in a short period of time. Performance evaluation is new to some of us. A lot of the builders and dealers in the Northeast, it's been my understanding, are not using that. It's probably to their big advantage because they're the ones with that R49 in the ceiling, and reducing that down just reduces our costs. It makes us more competitive with the fibrous systems that are out there. Okay, I think I'm at the end of my questions, and I've got 9 minutes, which is great. I think the summary of all this is really find out what your local jurisdiction is requiring. It's always a good idea to have a good rapport with the code official. I know that sounds kind of weird, but it's a good idea. Find out when you're doing a project, if you haven't been in a jurisdiction, find out what they're requiring. Kind of explain that you want to look at doing a simulator performance or an ERI path, not prescriptive, and kind of get a feel for if they're accepting it or not. And if they are, what are their conditions? What are the numbers they're enforcing on their ERI path? What exactly are the rules? And I do spend a lot of time with doing code presentations so that but most importantly, the dealer that's with me or the rep that's with me in that presentation understand what they require. So it puts us on the same sheet of music. So getting that rapport with the code official ahead of time is a good one. The other thing I would highly recommend as we get going, try not to argue with code officials. Some code officials actually like that, and I'm not being sarcastic, but a lot of them, they don't understand. They get backed up. They're not quite up on what we're doing. You know, we're the front end of the wave for sure, and a lot of the code officials don't quite understand it yet. So be patient with them. Each of the code officials usually have 8 or 10 or 12 subjects that they have to be knowledgeable on, and pretty much should know the code, but there's a lot in the code that they don't. So again, my summary of all this would be, let's look at performance paths, typically alternative paths, and also looking at the ERI, depending on the state. So those are the avenues we have, but the big thing we want to do is try to lower that R value in the attic, or ceiling, unvented attic or ceiling, because that's where we get uncompetitive. The more R's we need, we know the difference between the 2 different products, that makes us higher and sometimes out of reach, and we want to stay in reach. As people understand it better, down the road, we will have a much better opportunity, but hopefully that does it for now. I'm about 7 minutes early, which I'm glad. I usually go over, but I wanted to make sure today with everybody's schedule, I did not. So let's call it good. If you have any other questions, you can get a hold of myself at rnicholas@iceneemapola.com and ask me the question or give me a call. I didn't have it up there, and I probably should have. My number cell 503-703-8212, and please call me. That's our job. Our job is to support the dealer network and the rep network. Thank you very much. Good enough. Bye for now. Thanks for attending.